Physical diagrams. Introduction. We will discuss the following topics in this chapter: deployment diagrams, component diagram, combining component and deployment diagram, when to use physical diagrams. Deployment diagram. A deployment diagram expresses the physical relationship between software and hardware components in the delivery system. A deployment diagram is good at showing how components and objects are routed and move around a distributed system. Each node represents some kind of computational unit in most cases. A piece of hardware on a deployment diagram. The hardware is either a simple device of sensor or it could be a mainframe. Connections among nodes show the communication path over which the system will interact. An efficient deployment diagram controls the following parameters. It is very important: performance, scalability, maintainability, and portability. The following deployment diagram is a sample to give an idea of the deployment view of order management system. Here we have shown nodes as monitor, modem, caching server, and server. The application is assumed to be a web-based application which is deployed in a clustered environment using server 1, server 2, and server 3. The user is connecting to the application using internet. The control is flowing from the caching server to the cluster environment. Component diagrams. A component diagram shows the various components in a system and their dependencies. A component represents a physical module of code. It is often the same as a package, sometimes it may be different, since components represent the physical packaging of code. So a single class is present in multiple components. That class can be defined in only one package. For example, the Java string class is part of the java.lang package, but it turns up in lots of components. The dependencies among the components show how changes of one component cause other components to change. Component diagrams are used during the implementation phase of an application. Hence, the purpose of the component diagram can be summarized as: visualize the components of a system, construct executable by using forward and reverse engineering, describe the organization and relationship of the components. The following is a component diagram for order management system. Here the artifacts are files. The diagram shows the files in the application and their relationships. The component diagram also contains DLLs, libraries, and folders. In the following diagram, 4 files are identified and their relationship are produced. Component diagram cannot be matched directly with other UML diagrams discussed so far because it is drawn for completely different purpose. Combining component and deployment diagram. You can place the component diagram on the deployment diagram. This indicates which components run on which nodes. When a component has more than one interface, you can see which components communicate with each interface. In the example figure, the server application has 2 interfaces. One interface is used by the application package running on a PC, whereas the other interface is used by a configuration component running on the server. In this diagram, the liver unit UI and the liver unit client package both run on a Windows PC. The liver unit UI is dependent on the liver unit client package since it calls specific methods on the package. Although the communication is two-way in the sense that the package returns data, the package is not aware of who is calling it and is thus not depend on the UI. In the communication between the two healthcare domain components, both are aware that they are talking to another healthcare domain component. So the communication dependency is two-way. The two domain components run on separate nodes. When to use physical diagrams. Where to use deployment diagram. To model the hardware topology of a system. To model embedded system. To model hardware details for a client or server system. To model hardware details of a distributed application. Forward and reverse engineering. Where to use component diagram. Model the components of a system. Model database schema. Model executables of an application. Model systems source code.